Good morning, sixth grade. Hopefully, everybody had a great night. Today, we're going to move on to a new lesson now. We are on chapter 11, lesson 5. So, let's see where we can find the information. You're on your Google Classroom. Go to classwork, scroll all the way down here, chapter 11, and then we are looking for the completed notes on lesson 5 right here. Chapter 11, lesson 5. So, let's take a look at these notes here. Okay, now we're dealing with rotations on the coordinate plane, which means we're taking some type of shape, some type of an object, and we're rotating it either clockwise or counterclockwise on the coordinate plane. Now remember, coordinate plane right here. Okay, we've got our y-axis here. We got our x-axis here. We have our origin right here in the middle. You're going to need to know where the origin's at because sometimes we'll be rotating around that origin there. Okay, now remember, clockwise, we're going this way. Okay, counterclockwise, we're going the opposite way. Now, typically, we also start our 0 point, okay, when we rotate it here. So I'm going to draw this here again. Okay, as you know, this is typically our 0 degrees right here. Okay, over here, right along the x-axis, right along here. And if we rotate, let's go counterclockwise. We rotate counterclockwise up here. This takes us to 90 degrees. This takes us to 180 degrees. And this takes us to 270 degrees. If we are going counterclockwise. Now, if we're going clockwise, okay, that means 90 degrees is down here, 180 degrees is right here, and still we have, still 180 degrees here, no matter which way you go. And then our 270 degrees is up here when we go, when we are going clockwise here. Okay, so let's talk about rotations now. Let's see what a rotation is. It says a rotation is a transformation. Now remember, we had slides, we had flips, we had all that type of stuff the other day. So a rotation is a transformation in which a figure is turned around a fixed point. Okay, that point is known as our center of rotation. Okay, that's where we're going to take that object, that point, and we're going to rotate that object around that particular point. If I take my phone here and I say, okay, I'm going to rotate it around this corner here, that means that corner is going to stay in the same place, and I'm going to rotate it around that corner right there. Okay, that's our center of rotation. And it says rotations are also called turns. Okay, since a rotation image and its original image have the same shape and size, they are congruent. So we're not changing the size of the shape of the figure at all. All that stays the same. So that means that's still congruent. It's just in a different location. Okay, it says the images below show clockwise rotation of a figure with the center of rotation at point A. Okay, so let's take a look here. If this is my original here, okay, we have our original shape here. Here's point A right here, okay. This is where we're going to rotate everything around. So this point here does not move, okay. We're saying, hey, that's not going to move. So since that doesn't move, they want us to go 90 degrees clockwise, which means we're taking this here, this flag here, and if we start right here, even if we take this point here, we see this edge here, okay? Make it red here. This edge right here, if we're going to rotate it 90 degrees clockwise, this edge is going to end up being right over on this side here because this here is a 90-degree angle right here. Okay, this is 90 degrees right here, okay? So from here to here is 90 degrees. So all we're going to do is we're going to rotate this edge down 90 degrees down here. And as you see, that's what happened here. Now, the A looks like it's in a different location. It is. They just slid it down to get it so we have enough room in here. But as you can see, we rotated this down 90 degrees. So guess what happened to this side? It rotated up 90 degrees. You can see that side right there, okay? So you can see how everything changed 90 degrees. Now, we can say, hey, 180 degrees, which basically we're rotating it this time all the way around, okay? This is going all the way over in here, okay? Okay, so go from here. Now, if you want to, you can go from this point here, your 90 degrees, and rotate it another 90 degrees. Okay, as you see, we're here at a 90-degree rotation here. Okay, and if I rotate this figure another 90 degrees, that's what gives us our 180 degrees. So that's one way to look at it also. Okay, instead of going, hey, I'm going to rotate this whole thing 180 degrees on this side. Hey, yes, we can do that. But if you want to, you can do your 90 degrees first and then go up to your 180 degrees next. Okay, so next is 270 degrees. Okay, so probably the easiest way is to go from your 180 degrees and now rotate that another 90 degrees. So as you see, this side here, okay, which is our 180 degree rotation, this has to be rotated up 90 degrees here. So this line here is going to go straight across here, which is our 90 degrees. As you see, it is right there. Okay, so this is our 270 degree rotation from our original. Now, one thing you could have also have done, think about this. If I am going 270 degrees clockwise, okay, which means I'm going all the way around here, okay? If I'm going 270 degrees clockwise, why don't I make my life easier and just go 90 degrees counterclockwise? Because that will give you the exact same thing. So if I take this side here, okay, this side here, and I rotate it counterclockwise 90 degrees, that's going to bring this side over here straight down there. And as you can see, there it is there. There's this point right here. All I did is I rotated it 90 degrees counterclockwise. You can do that also. Okay, so let's look at some of these examples that we have here. Okay, it says draw the figure after a 90-degree clockwise. That's going to be important. We need to know which way we're going. Clockwise rotation about point C. So we have our ice cream cone. Now what I did, I drew a center line, okay, right down the center of this ice cream cone. And I know if I take that center line and I extend it down 90 degrees clockwise, this center line should be down along here. And as you can see that it is. And then I drew my ice cream cone around here and one from there. So here's my ice cream cone right down here. Now, I'm taking my arrow here, okay? It says draw a figure shown after 90 degrees clockwise rotation around point A. So here's my point A. I'm going clockwise. So you can, if you want to, you can draw your center in here. It's a little bit hard here with this mouse. And then I'm going to rotate this down 90 degrees. So as you can see, my center will now be down along here, and then I draw my arrow. So this is a 90-degree clockwise rotation. Okay, let's continue here. Let's see what else we have down here. Next page. Okay, now these ones here are a little bit more difficult. Okay, it says quadrilateral W, X, Y, Z has vertices at W is -4, -1, X is -2, 0, Y is -1, 3, and Z is -2, 4. So the first thing we're going to do is graph this figure. So right down here, we have our figure here. We have it graphed. We're good to go so far. Now, we got to graph its image now. Now, the image after a clockwise rotation of 180 degrees. Now, about vertex X. Okay, so no matter what, everything is going around vertex X here. Vertex X is right here, okay? We're going around that piece. That's our center of rotation. Now, remember what we said, okay? If this is 0 degrees here, and this is 180 degrees here, okay? As you see, these here are basically directly across from one another, okay? So we're just doing not a complete rotation, half of a complete rotation over to 180 degrees. So here's the easiest way to do this one here, okay? If this here is your W, and W we said is at -4, -1. Now, we are going around X. That's our center of rotation. Okay, so I know if this is my W here, if I draw a line that goes from W through X and extends all the way through, I can figure out where the new W prime is. Because if I look here, if I go up 1 over 2, slope, okay, rise 1 over 2, then guess what I'm going to do here from point X? I'm going to go rise 1 over 2, and this gives you my W prime. So there's my W prime right there. Okay. Now let's do the exact same thing. One of the easy ones to do is X. Okay. X is going, we got to look at the point here. What is this point? This point is W prime is 0, 1. So there's our 0, 1 there. Okay. Because we know this is directly across from it. So let's take a look here. Let's go to X. Now, X prime is going to stay the same. Okay. It's going to stay the same here. Because that's our center of rotation there. That's our center of rotation, so X prime will stay the same. Now, let's take a look here. Let's go with, let's start with Z. Z prime. Z is actually pretty easy because if we look here, here's my Z right here, and I'm going up through my X here. Okay, so if I extend this line straight up through X and keep on going all the way up through, okay, how far away is Z from X? Well, it's 1, 2, 3, 4. It's 4 units away from X. So guess what? Guess what Z prime is going to be? 4 units away from X also. 1, 2, 3, 4. So Z prime is located right here at -2, 4. So there's where your Z prime is. Okay, let's look at our W. Okay, that works pretty much the same way as, Y. It works pretty much the same way as the W did. So if we look here, here's my Y right here, okay? And here's my X, my center of rotation. If I draw my line and I bring it straight up through my X and continue on through, okay. So let's see. What is my slope here? Well, if I rise 1, 2, 3 and go left 1, okay, so it's -3 is my slope. I'll do the same thing here off the X. Go up 1, 2, 3 over 1, and here's my point here for my Y prime. So Y prime is located at -3, +3. So that was one way that we figured out all of these new coordinates for our quadrilateral when we did a rotation around point X. Okay, very good. Okay, let's continue on. Scroll down here. Okay, we're going to do the same thing here. Now, this one here, we're rotating it 90 degrees. It's going to be clockwise here, okay? So it says triangle EFG has vertices. E, which is 2, 1, F, 1, -1, G, 4, -1. Graph the figure, which we did here. Here's our figure here. Here's F, E, G. And its image after a clockwise rotation 90 degrees. So 90 degrees here about vertex F. So we're going around vertex F here, okay, 90 degrees. Now, then give the coordinates of the vertices for triangle E prime, F prime, G prime. Okay, the best thing to do with this, here's the best way. Start with either a horizontal line or a vertical line. That makes life so much easier when you're rotating it 90 degrees. Okay, so the line I'm going to start with right here, let me clear this a little bit, is the FG. As you see here, this is a horizontal line right here. Okay, now that's pretty easy to rotate 90 degrees clockwise because here's my horizontal line. So if I rotate it 90 degrees clockwise, that's going to give me a vertical line. So if I'm rotating it around my center of rotation, which is F, okay, that's my center of rotation there. So if I rotate this down 90 degrees clockwise, that means my new point for G is located right here. Okay, because look at this distance here. It's 1, 2, 3 units away from F. So from F here, G prime is going to be located 1, 2, 3 units away from F also. So my G prime is going to be 1, -4. Okay, that's pretty easy. Now, if you think about it, F remains the same. because that's our center of rotation there. So we're taking our center of rotation. F is still going to remain the same. That's going to be our 1 comma negative 1. Okay, so the only point that we have to figure out is where E is. And I think you'd be able to figure this out. So just think, if you have to, turn your head sideways there. Now mine's going the opposite way. It should be like that. Turn your head sideways there, and then you can see how it's turned. So we know that coming off of F, okay, if we rise 1, 2 over 1, okay, so that's 2. So 2 over 1 is 2. We're basically going to have to flip that and do 1/2. Okay, so then here we come from F. Okay, actually not 1/2. We'll take that because we're actually doing negative. We're dropping down and going over 2. So actually it's negative 1/2. So basically what we're doing, I think you ought to be able to figure out where E prime is right here. So basically if I said, hey, all I know from this point here, I'd have to go up 1, 2, which means I went to the right 1, 2, and then down 1. And that gives me my E prime. Very good. Okay, now we got to do some rules now, because we're going to start rotating things around the origin. Now, remember, the origin is 0, 0. Now, this makes life a lot easier. Okay. Now, there are rules. If we are rotating things around the origin, okay, if I rotate an object 90 degrees counterclockwise, okay, let me just draw here a coordinate plane here really quick here. And here, okay, this is my 0 point. Just think about this. Think this is my 90, okay, and go from there. Okay, so this is my 180, and this here is my 270. Now remember, this is all going counterclockwise. Now, clockwise, as you know, this would be our 90. Okay, this is still 180, and this here is 270. Okay, that's if we're going clockwise here. Okay, so if we rotate counterclockwise here to here, okay, which is the same as going clockwise 270 degrees. Okay. So actually we're going counterclockwise this way. It's the same as going clockwise 270. Basically, the rule that we are working with here, it says if we have our X and our Y, this is our original, all we have to do is switch the X and the Y and do the opposite of the Y. Okay, some of you guys are going, what does that mean, Mr. Spencer? Okay, let's take a look here. So if this is my original location of a point, which is 3, negative 5, okay, 3, negative 5. And if I want to rotate that point 90 degrees counterclockwise or 270 degrees clockwise, okay, then that means it says, hey, switch the X and the Y. So I switch them, but then do the opposite of the Y. Well, the opposite of the Y, the original Y was negative 5. So that makes it now positive 5. Okay. So it becomes 5, 3. Okay. Let's look down here at the next one. Rotate 180 degrees counterclockwise, which is the same as going 180 degrees clockwise. Okay. So all it says here, you have your original, your X and your Y. It says, hey, do the opposite of each one. So make X the opposite, make the Y the opposite. So let's take a look here. Okay. If we take a look here, it says 3, negative 5. So 3, negative 5. We got to do the opposite. So what's the opposite of 3? Negative 3. What's the opposite of negative 5? Positive 5. So our new location, when we rotate 180 degrees counterclockwise or 180 degrees clockwise, is going to be negative 3, 5. Let's look at the next one. Okay, let's look here. Okay, it says rotate 270 degrees counterclockwise, okay, which is the same as going 90 degrees clockwise. Okay, so what does it say here? Okay, you have your original, your X and your Y. You have this point here. It says, hey, flip them around. So make it YX, but then do the opposite of the X. Okay, so here's our original point. We got 3, negative 5. First it says switch them. So we would have negative 5, 3, but then do the opposite of X. So our new location is -5, comma, -3. You must follow these rules. You're going to have to follow these rules. These rules are extremely important. So let's take a look at some examples here. Okay, it says here, it says in the diagram below shows 3 clockwise rotations of a figure about the origin. So we're going about the origin here. Okay, so which means the center of rotation is here. It's our origin. No matter where you're at, it's the origin here. Here's the origin here. And here's the origin here. So here's what we're going to do. We're only going to take a point, okay? Let's take this point right here. Okay, they want a 90-degree rotation. It looks like it's going to go clockwise. So 90 degrees clockwise is right here. Okay, so it's going to be this rule right here. Okay, so if I take this point is located at 1, 2, 3, 3, comma, 1, 2, 3, 4. Say 1, 2, 3, 4. Okay, so it's at 3, comma, 4. So if it's a 90-degree rotation, okay, think about it, okay? It says flip X and Y and then do the opposite of X, okay? So that's this point here. So we had 3, 4, 3, comma, 4. Okay, 3, comma, 4. If we flip them, that gives us 4, comma, 3, but then it says make the X the opposite. So it'd be 4, comma, -3. Is this point located at 4, comma, -3? Well, 1, 2, 3, 4. Here's our X, yes. And go down, 1, 2, 3. There it is. So our new point is 4, comma, -3. Okay, so that's basically how it works. Following these rules are extremely important. Okay, now this one here, we're going clockwise. Let's take this point here, which is the same as this point here. Now, what does it say for 180-degree clockwise rotation? It says keep the X and the Y the same, but do the opposite. Okay, so this point here is 1, 2, 3. 3, comma, 1. 3, comma, 1. Okay, so it says, hey, make it the opposites. So this would be -3. Well, let's look here. 1, 2, 3. That's -3 and down 1. So it is -3, comma, 1. Very, very good. Okay, same thing here with 270 degrees. Make sure you're following these rules and go from there. So let's continue down. Okay, same thing here. Use your rules. Your rules are going to be extremely important here to follow, okay? So let's go here. Let's do some examples here. So it says a triangle has vertices. A is 2, comma, -5. B is 4, comma, -4. And C is 2, comma, -1. Graph the triangle and its image after a rotation of 270 degrees clockwise about the origin. Okay, let's talk about the rule. Okay. Since it is 270 degrees clockwise, use the rule, because they're the same, for the 90 degrees counterclockwise. Because remember, they are the same. Look at your rules. So we know that the rule is going to be, you have your original, your X and your Y, flip the X and the Y, and then do the Y as the opposite. So first thing you're going to do, you are going to graph these points from your original. Here's your A, here's your B, here's your C. Now, next thing we're going to do, best thing to do is write this stuff out. Makes your life a lot easier. If we know that A is at 2, comma, -5, okay? First, we're going to flip it. So it'd be -5, comma, 2, and then do the opposite of the Y. So A prime is going to be located at 5, comma, 2. So here's my A prime. Make sure that you label it. A prime is at 5, comma, 2. Now, let's go with B. B here is at 4, -4. So first thing we do, we flip them. So -4, 4, and then do the opposite of Y. Opposite of -4 is 4. So our B prime is at 4, 4. So here's the B prime right there, 4, 4. Let's do C. C is 2, comma, -1. 2, comma, -1. First thing we do is flip them. -1, comma, 2. And then do the opposite of the Y. So -1 becomes 1. So C prime becomes 1, comma, 2. So here's 1, comma, 2 right here. Connect your vertices right here. And then you have your new image, your new prime. Very, very good. Okay. as you can see here, the rules are extremely important. Let's go to this one here. A parallelogram ABCD has vertices. A is -3, -1. B is 1, 2. C is -1, -4. And D is -5, -3. Graph the parallelogram in its image after a 180-degree rotation about the origin. So it doesn't matter if it's clockwise or counterclockwise. It's going to be the same. Okay, so first thing, hopefully what you did is that you went through here and you graphed your A, B, C, and D. That is your original. Now, our 180-degree rotation basically states, hey, keep the X and Y the same, but do the opposite. So we know that A is -3, -1. So A prime is going to be the opposite of each one of those. That's going to be 3, 1. So here is 3, 1 here at A prime. B is 1, -2. 1, -2 is going to be the opposite of each of that. It's going to be -1, +2. So here is your B prime right here. C is -1, -4. Do the opposite of that. It's going to be 1, 4. There we go there. And D, do the opposite of -5, -3, which is going to be +5, +3. And here is the D prime right there, connected here to your vertices here, and you have your new image there. Very good, guys. As you can see, those rules are going to be extremely important for you to refer back and follow. Well, let's do a last little thing here. Let's look at rotational symmetry. So it says, if a figure can be rotated less than 90 degrees, I'm sorry, not 90 degrees, less than 360 degrees about the center, so the image matches the original figure, the figure has rotational symmetry. Okay, let's look at here. I got a little snowflake here. Hopefully we don't have to deal with any snow. We had a little bit of snow yesterday. That was pretty crazy. It's almost May. It says, determine whether the snowflake shown has rotational symmetry. Okay. If it does, describe the angle of rotation. Now remember, going all the way around, I'll start up here at 1. Going all the way around makes a circle. How many degrees are in a circle? 360 degrees. We know there are 360 degrees in a circle, okay? So if we take a look here, let me just erase this here. Okay, if we take a look here, we want to determine, does this have rotational symmetry? Okay, so if I take 1 and think about it, here's my center right here, okay? It's like a pinwheel, okay? If I take and I rotate this down to here, okay, will this image still look the same? Yes, it will. That means this 6 side is going to rotate up and it will still look identical to the original. If I do another one and rotate it down again, will it still look like the original? Yes, it will. If I rotate this down around again, will it look like the original? Yes. Keep going around. Yes, yes, and yes. It looks like the original. Okay. So yes, this does have rotational symmetry, okay? And we want to know what is the degrees that each time we rotate it, it looks the same. Well, if I rotate this down, I can rotate it a total of 6 times to get it back to its original place, which is right here. That's why I have 1, 2, 3, 4, 5, 6. So if I take my 360 degrees and I divide that by 6, that means every rotation that I'm making to get it look exactly the same as it did right here. Okay, that means it has 6, it's a 60-degree rotation each time because there's an even number of 6 rotations each time. Let's look at this star here. Okay, determine whether the star has rotational symmetry. Well, if I rotate it down, 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 boom, which is going to bring this 5 up here. And when I stop that figure, does it still look the same? Yes, it does. It still looks exactly the same. Okay, so that's 1 rotation, 2 rotations, 3 rotations, 4 rotations, 5 rotations to do a complete 360-degree turn. Since I need 5 rotations to do a complete rotation, okay, so yes, it does have a rotation. It does have rotational symmetry with 5 equal intervals. Each time I rotate this, it will be 360 divided by 5, which is 72 degrees. Think about this. If I rotate a rectangle, okay, if I rotate this rectangle, if I turn it 90 degrees, it's what? It's straight up and down. Does it look exactly like this original? No. But if I rotate it again, boom, it looks exactly the same. So a rectangle has only 2 turns, okay? 2 turns to get up 360 degrees. So a rectangle does have rotational symmetry, but it only has 2 turns or 2 intervals. So that each time I turn that is 180 degrees. Think of a square, okay? Think of a square here, okay? So if I rotate this down, it can look the same. If I rotate it all the way down there, it's 90 degrees, right? So I turn it 90 degrees, it looks exactly the same as the original square. Again, 90 degrees, the same thing. 90 degrees again. 90. So a square has 4 rotations to get to 360 degrees. Since it has 4, that means the angle of rotation is 90 degrees. So guys, I hope you understood a lot of what we talked about. There's a lot of important information, especially as you know these rules here. If you're confused about any parts of the lesson at all, please rewatch it. Send me any questions that you may have. Other than that, guys, have a great day. Enjoy yourselves. Make sure you work on your homework today. Check your answers on Google Classroom, and we'll go from there. See you tomorrow. Bye-bye.